along the way. There is more to building the Skyray 35 than the half-A version. The tools you use to build the smaller version will be used with the addition of a drill and a soldering iron. Also, this version needs more shaping, so expect to do some carving and a lot more sanding. The X-Acto 26 blade in either a number 2 or number 5 handle will be very useful, and some coarse grit sandpaper of about number 80 grit will help speed up the shaping procedure. As usual, study the plans and the construction steps before you begin gluing wood together. It will save you time in the long run. The wing construction is where the Skyray 35 is most different from its smaller counterpart, so let's begin there. The first step in any built-up wing is selecting a flat, straight working surface. Since it is necessary to hold the wing in place with pins, the surface cannot be too hard. There are several materials on the market that will work, including soft pine, homosote, and the one we chose, a section of ceiling tile. Whatever material you select, check it carefully for warps and reject it if it's not perfectly flat. The goal is to build a wing that is true and warp-free, and every degree you fall short of this goal will diminish the model's flying ability. Begin construction by taping or tacking a piece of waxed paper or saran wrap over the plans to keep the components from becoming glued to them. Next, pin the left and right spruce spar to the wing plan, butt gluing them together and reinforcing the joint with the plywood wing spar doubler. Sig Bond or other aliphatic glue is a good choice here, but always pre-glue any joint made on end grain. To do this, smear a light coat of glue on the end of each spar, let them dry, add more glue, and join together. Make certain everything is flat and in line. Add the plywood doubler, holding it tightly to the spars with small clamps or spring clothespins. The Skyray uses plywood ribs and false ribs rather than balsa. This stronger material allows the use of fewer ribs while still maintaining strength. Adding the false ribs helps keep the airfoil shape on the leading edge by not allowing the covering to sag in that area. The result is a light model without sacrificing strength. All of the plywood parts are die cut, but you still need to use a modeling knife to completely separate them from their plywood sheet. Sanding the back of the sheet will help, but eventually you will need to use your knife. Once you have freed the part from its plywood sheet, lightly sand the edges to remove any fuzz or splinters. It's difficult to push a pin through plywood, so glue a strip of 1/4-inch square balsa along the alignment tabs at the bottom of each wing rib. CA is a good adhesive for this procedure, and you might like to use a spray of accelerator to speed setting. Glue the ribs to the spar using the light ply right angles provided to keep everything lined up and square. If the ribs are warped and fail to align with the plan, just make certain they are aligned with the bottom spar and let the trailing edge fall where it may. Once you have the wing glued securely from the spar forward, you can bend the ribs into alignment before adding the trailing edge. Add the top spar and the remaining doubler. Once the spar has been glued in place, attach the leading edge. Since this is a difficult assembly to pin in place, align it a couple of ribs at a time. Hold the leading edge securely to these ribs, add thin CA, and hit it with a spray of accelerator. Next, move on down the span and repeat the procedure until the entire leading edge has been tacked into place. Additional adhesive can be added once everything is lined up. The trailing edge consists of a top and bottom piece, each made up from 2 sheets of 3/32 by 1.5 by 24-inch balsa supplied with the kit. 2 of these sheets are joined to form each. Use one of the light ply triangles to cut the scarf angle on the end of one of the sheets. Then use that sheet to lay out the angle on its joining sheet. Use a straight edge to ensure accuracy. Glue the sheets together by pinning them down on a flat surface with waxed paper under the joint. Check their alignment with the straight edge. Repeat the procedure to form the other trailing edge. Coat the bottom trailing edge of each rib with glue and add the trailing edge. Take extra pains to keep it and all the ribs in alignment. Then use pins and spring clothespins to hold it in place until thoroughly dry. Repeat the procedure with the top trailing edge, again using spring clothespins to keep it all in line. Add the half ribs by inserting them between the spars and the leading edge at an angle and then straightening them. Glue them in place with either CA or SIG-Bond. Once the entire assembly is completely dry, you can remove the wing from the plans. You will need to drill an 1/8-inch hole through both the bell crank mount and the bell crank spacer. Use the plans to make certain you have located the hole properly, and be extra careful to drill the holes at an angle perpendicular to the surface of the part. A drill press makes this job easier, but an electric hand drill will suffice if you are careful. Epoxy the spacer and mount together, making certain the holes are aligned. If any epoxy creeps into the hole, you will need to re-drill after it dries. Insert the push rod into the hole provided in the bell crank and solder a number 3 washer on both sides to hold it in place. A piece of sandpaper makes a good spacer when soldering to protect the bell crank and guard against binding. Cut the 027 lead-out wire provided into 2 equal lengths and attach to the bell crank as shown on the plans. To keep both lead-outs the same length, measure 2 inches in from the end of the wire and begin your loop there. Be careful not to kink the wire or make the loop so small that it binds the bell crank. Secure the loop by wrapping evenly with the thin copper wire provided for at least ½ inch. Then fold the lead-out wire back upon itself and continue wrapping with the copper wire back toward the loop. When finished, cut off any loose ends and give the copper wire a thin coating of epoxy to keep it from unwrapping. Make sure there are no loose ends sticking out that might bind the bell crank movement. Once this is done, assemble the bell crank components to the plywood platform and epoxy the entire assembly in place. The entire model will be held to the lines by this assembly, so make sure you have strong glue joints. With the bell crank assembly installed, sheet the top of the wing with 3/32 balsa. Note that the balsa butts up to the spar rather than going over it. This procedure is an ideal place to use aliphatic glue or a slow-setting CA. Make sure you use a straight edge when trimming the balsa to fit to avoid cracks. The bottom center section is planked in the same manner, except that you must cut out a slot for the push rod. The idea here is to allow the push rod to operate freely and at the same time not make the slot so big that it allows fuel and dirt to enter the wing. Before adding the wing tips, trim the excess trailing edges and spars flush with the outboard wing rib. Then glue on the wing tips, making sure they are properly aligned and perpendicular to the ribs. Epoxy the brass eyelets to the bottom of the inboard wing and reinforce them with 3/32 scrap balsa. It is important that these eyelets are located just as they are shown on the plans, and that they are reinforced enough to stand a certain amount of stress. When the epoxy is cured, thread the lead-outs through the eyelets and form a loop on each just as you did at the bell crank. Again, make certain the loops are even and that there are no kinks. The entire wing assembly is now ready to shape and sand smooth. Begin with the leading edge, carving it close to the final shape with a number 26 blade in either a number 2 or number 5 X-Acto handle. Use the template provided to keep checking the shape as you go. When you feel you're as close to the final shape as your skill with a carving knife will allow you to go, finish shaping with sandpaper. Begin with 80 grit to remove balsa quickly, and then use 100 and 150 to finish up. Before sanding the trailing edge, let's build the fuselage. The Skyray 35 fuselage is cut oversize, but we will cut it to shape once we have the motor mounts and doublers installed. The Skyray is designed for a Fox 35 engine, so if you intend to use another power plant, be sure you adjust for the different size. If your engine is wider than the Fox, you will need to cut away enough balsa from the fuselage to increase the distance between the mounts. If it is smaller, you will need to add hardwood shims to decrease the distance. When you are certain that the distance between the hardwood motor mounts is correct for the engine you have chosen, apply epoxy to one of the fuselage doublers and then lay the fuselage in place. Be certain that the fuselage and the doubler are aligned properly. Epoxy the maple motor mounts in place and fill in with balsa as needed. Sand the motor mounts flush with the fuselage. Add the other plywood doubler. Remember when applying epoxy that there is a right and a left doubler. Clamp or weight the nose assembly and allow the epoxy to dry. Finish by sanding off any excess epoxy that is oozed out. Begin shaping the fuselage with the number 26 blade. Note that the area where the stabilizer is attached is left flat and thick enough to provide a firm platform. The nose area is carved to match the plywood doublers. The rest of the fuselage is carved to a teardrop section for lightness, streamlining, and appearance. When carving, go easy and do not try to take too big a bite. Also, be careful. X-Acto takes great pride in the sharpness of their tools, and that blade that does wonders on balsa can put a nasty slice in your finger. Smooth up the carved areas with number 80 sandpaper and then use progressively finer grits until you have a nice smooth surface. A good choice is to follow the number 80 with 100 and then 150. Save the finer grits until after the first coat of clear dope. It's now time to assemble the wing to the fuselage, and this may take some fitting. We found that the first step was to sand the trailing edge to shape. You can only go so far here, as too much sanding will get you beyond the point where the top and bottom are glued together and create a gap. You may also find that the wing opening in the fuselage will need slightly enlarged. This is most likely just a matter of sanding it to match the plywood doubler. Go easy, as if you remove too much, you will create a gap that will need filling after the wing is attached. Your goal is to get a tight fit that is not so tight that it binds and forces the wing out of alignment. The wing can be glued in place using epoxy, CA, or SIG-Bond. Just remember that this must be a strong joint. There are various ways to fill the inevitable gaps between the fuselage and wing. Some modelers build up a fillet of successive coats of adhesive, and this can look quite acceptable for the type of model we are building. A more advanced approach is to use a fillet material such as SIG's Epoxylite. While this will give your Skyray an excellent finish, keep in mind that as a novice flyer, you will put a lot of wear and tear on these first models, and it might be better not to get too particular until you have gained flying experience. The stabilizer and elevator should have all edges sanded round before they are attached. Then lay the stabilizer over the plans and mark the locations for the SIG Easy hinges. With an X-Acto knife and a number 11 blade, cut a slot in the elevator about ½ inch deep and slightly larger than the width of the hinges at each hinge location. These slots should be at the center of the thickness of the elevator, and you must be careful to keep the blade parallel to the surface of the elevator. Angling the knife will cause it to cut through the surface, making an ugly gash in your elevator. A good way to ensure accuracy is to build a simple jig for cutting hinge notches. Since the elevator and stabilizer are both 1/8 of an inch thick, you can use a piece of 1/16 inch by 1/4 inch hard balsa to guide your blade. Sand the balsa just a bit thinner to allow for the blade's thickness. Lay the part on a flat surface, pulling the edge where you want the hinge slot tight against the balsa guide. Then, with the blade flat on the guide, you should be able to cut an accurate slot. When cutting the slot, it's a good idea to insert the blade from both sides, working toward the middle. Insert the hinges in the slots cut in the stabilizer, and then use this to mark the slot locations on the elevator. Use the same method used on the stabilizer to cut the elevator slots. Now slide the elevator onto the hinges and apply a bit of CA where the hinges meet both the elevator and stabilizer. You should flex the assembly after the CA sets to make certain you have not glued the parts together. Drill out the bottom hole of the control horn to accept the 3/32 inch push rod. Insert the push rod and solder a number 3 washer on each side of the control horn to keep it in place. Install the control horn on the elevator, making certain you did not bind the push rod from side to side. With the bell crank in neutral, slide the stabilizer assembly fore and aft along the fuselage until the elevator is in neutral. Pin the assembly in place and carefully check alignment. Once you are certain everything is perfectly aligned with both the fuselage and wing, fasten the assembly in place with CA. The rudder is attached to the fin with a 1/4 inch offset to the right as viewed from the rear. To make a gap-free joint, prop the rudder up 1/4 inch on a flat surface with a perpendicular edge, just as you did with the half-A Skyray. Use a sanding block to angle the edge of the rudder to match the edge of the work surface. Glue the rudder to the fin, round all the edges of the fin assembly, attach to the fuselage, and check for proper alignment. The basic assembly of your Skyray 35 is now completed. The model is now ready for clear dope, and we have found that SIG light coat is hard to beat. Thin only as much as necessary for the brush to flow freely. It will help keep the bristles from pulling out if you don't try to brush the dope out too much. Just let it flow smoothly with a minimum of brush strokes. Pay particular attention to the top of the ribs and anywhere that the covering material will be attached to the wing. Apply 3 coats at this time. Allow each coat to dry thoroughly, then sand lightly between coats with number 150 or 220 sandpaper. The object is to obtain a smooth finish beneath the covering material, but while you are at it, you may as well get a couple of extra coats on the rest of the Skyray. After 3 coats of clear, you should have a good surface for applying the covering. There are many types of covering that are suitable, such as silk span, silk, and monocoat, but we will be using SIG Coverall for this model. We will attach it with Stixit and use heat to both adhere it to the structure and to shrink it drum tight. Begin by applying a coat of Stixit to the wing's leading edge, trailing edge, root, and tip. Do the top and bottom panels on both sides. Allow the Stixit to dry and then cut a piece of coverall slightly larger than one wing panel. Make sure that the grain of the covering material runs span-wise, or you will get sags in your covering job. To attach the coverall, you can use an ordinary household iron, but if you can buy or borrow a regular covering iron, the task will be somewhat easier. Lay the material out on the bottom of one wing panel, as it's best to cover the bottom of a wing first. Then tack it on all 4 corners while stretching it enough to take out most of the wrinkles. You do not need to stretch the material drum taut at this point. Coverall has excellent shrinking qualities, so it is more important to keep the wrinkles out so that when you shrink it, you will have a nice, smooth covering job. After tacking the corners, iron the covering down to the rest of the wing. Do the root first, then work your way toward the tip, smoothing out wrinkles and pulling the covering taut as you go. One covering problem that did surface with the Skyray was caused by the thin plywood wing tips. The 1/8 inch thick tips leave very little area for the covering to adhere to, particularly when both the top and bottom covering must adhere to the same surface. We solved the problem by first attaching the bottom tip covering, then recoating it with Stixit and fastening the top covering to that. The top covering should be wrapped around the leading and trailing edge so that the seam between it and the bottom covering is on the bottom of the wing. Trim the excess covering with a single-edge razor blade. When trimming, try to obtain as neat a seam between the bottom and top covering as possible. With the top and bottom wing panels covered, the next step is to heat shrink the covering to remove all wrinkles. Be a little cautious here, as coverall seems to shrink forever if you keep applying heat. Just shrink it taut enough to look good and obtain a nice, smooth airfoil. You can shrink this material with your covering iron, a household iron, or a heat gun. If you can shrink the bottom and top panels evenly, you will help avoid warps. This is a good time to attach the single landing gear, as it gives you a handle of sorts while doping. Use the Skyray plan to locate the point where the landing gear enters the fuselage and drill an 1/8-inch hole. Insert the landing gear, sweeping it back as shown on the plans, and use the landing gear strap to drill 2 1/8-inch holes through the fuselage. Attach the landing gear strap using the 440 by 1-inch bolts and blind nuts supplied. Apply at least 3 coats of clear dope to the entire model to seal the coverall and give the wood a smooth, glossy surface. The model should be sanded lightly between coats, but take extra care when sanding the fabric covering. If you sand too hard or long, especially where there is a rib or other structure beneath the covering, you could sand through. After sanding, always wipe the model down with a tack rag before applying the next coat. In reality, your Skyray can be flown as soon as you have applied enough clear dope to seal the fabric and wood. If you are not too certain of your flying skills, take your Skyray out to the field and make your mistakes before you go the extra step to produce a thoroughly finished model. Once your Skyray 35 has been painted to your satisfaction, it's time to install the engine. We chose the venerable Fox 35 Stunt for its reliability. Installation is straightforward. Just mark the location of the mounting holes using the engine as a guide, drill the holes, and attach the engine with the 440 bolts and blind nuts supplied with the kit. A washer between the front of the engine mounting lug and the motor mount will add a bit of engine offset, so the thrust will help keep your lines tight during flight. The fuel tank is installed according to the location shown on the plans, making certain that the fuel pickup line is lined up with the engine intake. Use the J-screws provided and rubber bands to hold the tank in place. A piece of RC foam rubber between the tank and fuselage will help cut down on vibration in the tank. Attaching the wheel completes the Skyray 35 construction, and it's time to fly. If you enjoyed flying your half-A Skyray, you're going to love the Skyray 35. It's an ideal intermediate step into a wide range of exciting control line events. The Fox 35 powered Skyray flies using the same principles as the half-A version, in that the controls work the same. However, the similarity ends when your 35 roars to life and you begin that first flight. The heavier, more powerful aircraft handles much more smoothly than the smaller models, and that will enable you to improve your flying skills considerably. Follow the engine's instruction manual as to starting procedure and proper fuel. For most control line engines, you will need to add additional lubricant to the RC fuel available at many hobby shops. Starting the larger engines demands caution. If you prop the engine by hand, you should wear a glove on the propping hand to protect you from sharp propellers. For your first flights, keep the engine setting a little on the rich side. This is especially true with a new engine that is not totally broken in. The Skyray 35's takeoff is different than the half-A because it has a landing gear and can be taken off from the ground. Your helper should release the model without pushing it. Hold the controls in neutral to allow it to gain speed and then add just a slight amount of up elevator. Once the model has climbed to about shoulder high, level off and fly a few laps to get acquainted. As soon as you feel comfortable with the larger, more powerful aircraft, go ahead and review the maneuvers you practiced with the smaller Skyray. They are the climb, the dive, the loop. When the Skyray is gliding, it will have less pull on the lines, so you may find that you will need to backpedal a bit to maintain control. Keep the nose down to hold your flying speed until the airplane is close to the ground, and then level off to allow it to slow down. If it begins to stall, drop the nose, but be sure to flare out just before touchdown. Only experience will teach you how fast to approach a landing, and you will make a lot of lousy landings while learning. Fortunately, you'll have a lot of fun at the same time. We promised to try some new maneuvers with the Skyray 35, so let's get back in the air and give them a try. When in inverted flight, your controls are reversed, and this can cause some confusion to the beginner. One way to help remember that down is up and up is down is to hold the control handle with your palm up once you enter inverted flight. This makes it much easier to use the proper control than holding the handle normally and trying to remember which way to move the handle to make the model climb while inverted. It's best to enter inverted flight at a higher than normal altitude, and this means that performing half a loop is an excellent way to get there. Just neutralize the controls as the model becomes inverted and level at the top of the loop, and you will be flying inverted. Rather than trying to complete a lap of inverted flight, it is best to add down elevator shortly after achieving an inverted attitude so that the model climbs up and over to an upright flying attitude. Each time you practice this, stretch out the time spent inverted until you can complete a lap or more. The outside loop can be entered from inverted flight and is performed just like the inside loop, except that down control is used instead of up. To perform this maneuver, fly inverted and level at a fairly low altitude. Then apply down control. The model will climb from an inverted position and then fly over the top of the loop. At this point, apply more down so that the model will complete the bottom half of the loop at a safe altitude. As you gain confidence, use less down at the top so that the model will recover closer to the ground, making the loop more round. The more you practice, the more perfect your loops, both inside and outside, will look. Our final maneuver for this video is the figure 8, which is nothing more than stretched out inside and outside loops flown back to back. Begin by applying up control just as if you are going to perform an inside loop. The model flies over the top of the loop and starts down. Begin to apply down control until you perform an outside loop. However, instead of allowing the model to go all the way through the outside loop into inverted flight, use up control to return it to the same point where you began the inside loop. Level off, and you have completed a figure 8. The figure 8 maneuver completes your basic control line training. It's up to you now to practice until you can perform each maneuver smoothly and with confidence. As your skill increases, you may choose to try other forms of control line flying, such as Navy carrier or precision aerobatics. There are contests held each year for these events. But whether you intend to fly strictly for fun or plan to enter the exciting world of competition, control line flying will provide you many hours of hands-on model aviation. It's a hobby that lasts a lifetime.